Hello everyone, welcome to the class 317 Digital Signal Processing 1. Today we will have a review for the midterm exam. The exam will be next Monday. Alright, now let me write down the information. Okay, ECE317, the 8th week, Friday's class, and today is for the review. Just review for midterm exam. The first thing is about the time. The exam will be on Monday. Monday morning. Monday morning from 10 to 11. This is a class time, just a normal class time. Then plus 30 more minutes for, you need some time to prepare the file in the PDF style and upload to the Blackboard. So I gave you 30 minutes. Okay. So totally is 10 to 11:30 morning. And for the upload your result in the Blackboard, I like you can prepare before you go to the exam. Make sure you already know how to upload the files. Same as homework. But homework is work in group, so I'm not so sure. Maybe some of you guys never submitted homeworks before. So if that is your case, you try to do something, make sure you really know how to upload the file in PDF style to the Blackboard. There will be different ways depending on your device, your software, but you need to make it in a PDF file and upload to the Blackboard. Alright. Yeah, don't just like you never do that, never did it before. You just try to do it in that 30 minutes. That will give you you will have some risk, maybe you somehow late. Yeah. So try to do it before. Try to understand how to upload the files before start the exam. Alright. This is exam time. And okay, what else? Oh, Monday will be the March which day? March. Yeah. Okay. March 8th. Okay. March 8th. Oh, this is the holiday, huh? International Women's Day. And not exactly holiday in America, but it is a holiday. Anyway, okay, this is exam time. And then about the exam itself, it will contain 4 problems. 4 problems. Similar with homeworks. And I have a sample in the Blackboard. Okay, you can find it. You go to the lecture material. I put it in the lecture material. You go to Blackboard, go to the lecture material. You can have a sample that is a exam of last semester. But the problem might be different. No, the problem was similar with homework, not similar with the exam of last time. It's still similar, but not exactly the same. Some part will be different. Yeah. Okay, so this is the problems, and what else you need to do before the exam? Yeah, you need a formula sheet. You need formula sheet. This one we are working, you work at home, and actually it is open book, open notes, even open internet. The only restriction is time. Your time is limited. You have to finish by this time limit, right? But I still think you need to prepare a formula sheet. That will be helpful, because the material might be there's a lot, right? If you do not have a formula sheet, we want to find something, some formula, some definition, or some theorem, you need to check everywhere. That will cost you time. So prepare a formula sheet. That will be helpful. Before you start the exam, go over all the material and write down all the important things you think they are important that you write down on that paper. And during the exam, that can save you time, or that will be easy, right? Easy to find the formulas. Okay, that's a formula sheet. And next, what else? And then okay, we have one more office hour. It's my office hour. The same day, Friday, right? Friday morning. I suppose you watch. This is a video, recorded video. I will post in the YouTube, and I suppose you will watch this video in the morning of Friday, and then in the afternoon, I give you 1 hour for the office hours. I put in 4 to 5 p.m. You go to the Blackboard, go to the Zoom meeting, then you can find the link to the meeting, Zoom meeting. Alright. Okay. These are generally what we will do for the exam. And if you have any more questions, you can ask me during these office hours. Alright. Okay. Then the coverage. Your cover, actually so far we have 2 chapters, right? Chapter 2 and 3. Almost all of the chapter 2, but I think we only have, so far we have part of chapter 3, right? All of chapter 2 and part of chapter 3. Let me show you. Let's look at the textbook. Okay. Alright, it's here. So chapter 2, we cover chapter 2 in section 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we cover the whole chapter 2, but section 10, 2.10, it is not included in the exam. Alright, so now we have 9 sections for chapter 2. 9 sections for chapter 2. This one, to the 0 just introduction to 2.9. Alright, 2.9. And then chapter 3, we have Z transform, properties, inverse, and properties. This is also table. Then the Z transform and the LTI system. Yeah, we have the first 1, 2, 3, 4, 5 sections. Yeah, no 6, no 3.6. 3.6 is another kind of Z transform. We don't cover this. We didn't cover this one. All right. So chapter 3 we have 1 to 5, 0 to 5, 0 introduction. Yeah. 3.0 to 3.5. Okay. Yeah, almost the whole 2 chapters. But the last section, we do not have last section. Okay. And I think at the last section we have another thing related. We didn't have similar with the last section. It's a different kind of. Let me see. Chapter 2.1 is signal. 2.2 is the system, different kind of system. 2.3 is LTI, then properties, then linear constant coefficient equations, then frequency domain analysis, eigenvector, semi applied complex. Yeah, we do not have this one. We do not have 2.6.2. Yeah, it's a special kind of input. We didn't discuss it. Okay, then 2.7, 2.8, 2.9. Okay, yeah, just know 2.9 is in the table. The all the material of 2.9 is kind of summary in the table. Yeah, no 2.6.2. Okay. No 2.6.2. This one is no 3.6. Okay. This is the coverage. And among these materials, we have two kind of important things. They are the tables. The first kind of tables are the Fourier tables, Fourier transform. The second is Z transform. Each one we have 2 or 3 tables. You can find all these tables from the textbook, and I also posted these tables in the Blackboard, so you can also download it from Blackboard. Yeah, even like you just watching the Blackboard. But as I said, you'd better prepare in a paper. In your screen, like you have computer, you connect to the internet. Then in your screen, you have like one table. But totally here is 1, 2, 3, 4, like 5 tables. If each table you have paper, that will be convenience, right? So you try to compare tables. You can try to print it. If you cannot print it, you can even copy it by hand on the papers. Just I think 10 minutes. Yeah, 3 or 5 papers, 10 minutes. That will be enough to prepare the tables. Yeah, just copying the papers. Okay, so these are the coverage. What else? Yeah, I think that's all in generally. Then let's go over the material. I go over the material, not follow the order at the sections. Yeah, actually, the order of these sections are the order when we learn it, right? We learn the material in the first section, second section, step by step. Now we have all of these. As you might review, we'll combine all of them together as several topics. Okay. First one is about signal. We have several things. First one, of course, how to represent it. Represent the signal. This one is like a background. We do not have any problem just for this one, but you should know that, right? You can write it in formula. The formula, as an example, I put like a 1/2 to the nu of n plus 1. Okay, so when I give a signal in this formula, you should know what it is. If you want, you can give a graph of it. So the second way is a graph. Right? Graph like this one, you will have something like this. Right? Yeah. Here should be 2. Well, n is -1. Here's 2, and before that it should be 0. Right? This one looks like this. This is a graph. And you can also list. You list the value. Then this will be 2, 1/2, 1/4, and so on. And here is n equal to 0. Right. We can have 3 different ways to represent the signal. And then, secondly, we want the operations on signals. Right. we can add two signals together. We can times. Okay, this is convolution. Okay, to add, you can time, right? You can also scale, time scale, right? It's x1 plus x2. You add two signals together. You times together the x1 times x2, right? Time scale, like you use a times x of n, right? Things like that. And you can also like you can also have subtract, right? Subtract even more, like ax1 of n plus bx2 of n, right? You can have a lot, so you can do operation on signals. And among them, we have something. We have name. We have a shift. That is xn minus nd, right? Shifted by nd. This is shift. And convolution. So x1 of n convolution with x2 of n, which is summation of x1 of k times x2 of n minus k. K run from negative to positive infinite. This is a convolution, right? Okay, so they are operations on signal. You start from signal and do two signal or one signal, right? This is one signal, this is two signal. Then you do some operation, some calculate. You have a different signal. So this is an operation from signal to signal, right? And we also have transform. Transform is transform of signal. You start from signal and the result, it is not a signal, it's a different kind of function. So we have dtft. From x of n, we can have capital X of e to the j omega. And z transform from x of n, we can have a capital X of z. X of n, remember what it is? This is a summation of x of n times e to the negative j omega n for all the n's to summation. And the z transform is also summation of x of n and z to the negative n, and run from negative to positive infinity. Right? This is z transform. And for z transform, you also need to consider RC. Okay. This is we have two transform. This one is a signal to signal. This one is signals to function in omega or z. Right? Omega or z. Right? Yeah. That one I call it operation, and this one I call it transform. Transform to different domain. Right. For signals, I think we have these three. Right, we have three. Of course, you need more details inside, like how to do the convolution. Yeah, you can use the formula, and if both x1 and x2 they are finite lengths, the signal with finite non-zero values, you can list the table. Use the table way to find the convolution. Even some signal with infinite length, you still can do that. Suppose x1 and x2 they are not too complex, you can do that. You list the table, then you do summation. Yeah, remember that? Yeah, you can check the related courses, the notes, and my lecture, record the video or the textbook. You can find a way to find them. Okay, and then you can use a transform to find them. Yeah, here I just write in this way, but actually they are related. When you calculate convolution, you can go to the transfer domain. You perform multiplication of Fourier transform or Z transform, and then do inverse transform to go back, right? To go back. And here, okay, yeah, and right here, and right here. So special things, the x of n convolution with x2 of n convolution, and related with x of z times x2 of z, or x1 of e to the j omega times x2 of e to the j omega. So we use this a lot. We use this a lot. And here you need the inverse transform, right? You go to the transform into z domain or w domain, then do inverse transform. You go back, so you need to perform inverse z transform, and this one you need a partial fraction. Yeah, you need partial fraction. Do partial fraction to find the inverse transform. All right. Okay, so for signals, I think we have these four large topic. Right. Then second thing, we have system. For system, the first one, we have some general information. We have the type of system. We have memoryless system, we have stable system, we have causal system, we have five, right? A time invariant system and a linear. Right? Time invariant system, we have linear system. Okay. We have five different kind of system. Yeah. Different type. You can separate system in different way. So linear or non-linear, time invariant or not time invariant, causal or not causal or anti-causal, stable or not stable, right? Unstable, the memoryless or not memoryless. Yeah. So you should know we have this different type of system, and then all the rest they are related with LTI system. All the rest part they are related with LTI system. The first one, LTI system. We have the how to say. We have the way. Okay, I write this. We can use difference equation. I write it this way: difference equation to describe a system. The summation ai y of n minus ak y of n minus k equal to summation bk x of n minus k. Right? We can write it this way: for different k run from 0 to some m, here k run from 0 to some n. Now we can use this way to describe a system. We can also use the impulse response. H of n to describe the system. And then we can also use the frequency response. H of e to the j omega. We can use this one to describe the system. And we have the fourth way. We have the transfer function. H of z to describe the system. So we have these four ways to describe system. If you know any one of it, these four, you know any one of it, that means you can have all the information about the system. And these four ways, you should know how to transfer If you know the equation, then you should know how to find the frequency response. And also, go this way, or from here to here, or from here to here, how to find the transfer function. And then from the transfer function or the frequency response, you can find the impulse response, or go back. Right? This way, usually people do not go through from here to here directly. You try to solve this. You use frequency response, then inverse Z transform, or transfer function, then you inverse Z transform. You can have H of n. Right? And for transfer function case, you also need to consider RC. Don't forget, different RC, the thing might be different. The property of the system might be different. Causal or stable or whatever. You need to consider these. Alright. So this is so far we have 4 different ways to describe the system. Describe the system. Describe the system. Okay, then we can consider the input, output relation. If you know input, how to find output, or you can also go back. Actually, that depending on the way to describe the system. Right? So here we have these 3. Okay, so I'll say by impulse response, input is X, output is Y. Then by the impulse response, the output or equal to input convolution with impulse response. Then by frequency response, I just write the function. Okay. By frequency response, we have y of e to the j omega equal to x of e to the j omega times h of e to the j omega. Then we perform the inverse dtft. We have y of n. Alright. This is so you have x of n, how to find y of n. Then by frequency response, this is frequency response. Another is by h of z, the transfer function. By transfer function, similar, we have y of z equal to x of z times h of z. And then by inverse z transform. Inverse z transform, we can have y of n. We want to have y of n, so you can also work by z transform. You can get this one. And also we have some special case, 2 special case. The first one is if x of n is e to the j omega 0 n, then y of n equal to h of e to the j omega 0 times e to the j omega 0 n. And the second case, if x of n equal to a to the n, then y of n equal to h of a times a to the n. Actually here you need more requirement. If this a is an element inside the RC, a belongs to RC of h. You need this requirement. Then you can work like this. Alright. 2 special case. And for the first special case, this is a complex case, right? You can also have the real version of this formula. So we have the 1 prime. If x of n is cosine of omega 0 n, then we have y of n, that will be magnitude of h of e to the j omega 0 times cosine omega 0 n plus angle of h of e to the j omega 0. Right? We have these. And for sine, yes, in sine version, x of n is a sine of omega 0 n. Then we have y of n, similar. It is still the magnitude of these frequency response, now times the sine of omega 0 n plus the angle of frequency response. Yeah, so we have this one. Alright. This is the input and output. In most cases, we have this one and this one. In most cases. And for special case, if you input is a sinusoid is some n, e to the n, or just some number to the n. That's the power. Then you can use these two formulas to get an output. Okay. And now for the input output, this is fourth. For input output, we have more details if initial value is requested. If find the output when initial condition is given. Then we have 3 steps. Remember, we need to find step 1. Find the homogeneous solution. There will be yh of n in a form like alpha 1 lambda 1 to the n until alpha the order. I don't know what's the order, like m lambda m to the n, things like that. Alpha 1, alpha m, they are free coefficients, any possible values, right? Things like that. And step 2, find the particular solution by DTFT or the Z transform. Okay, here let me see, I have this input output, right? The input output here. So when we say we find the input output by convolution or by this one or by this one, in those cases we didn't consider anything related with the initial condition, right? So you regardless, you just think you have input output like that. Then this solution coming from here, they are particular solution. So you can use either way, DTFT or the Z transform. Right? You can use these 2 ways to find that particular solution. But for this one, the particular solution here, the RC might be different because H of Z might be used different than RC. Then the Y will be different, right? Okay, so here, for this, if you use Z transform to solve problem here, then use any RC will be fine. Yeah, you can have different choice for RCs, right? You can use anyone. Use different one, then the result will write in different form. The formula maybe looks different, but actually this should be same. If you give a graph, you will see. No matter which method, which RC you will choose, the final answer will be same. Okay, and then step 3. No, particular solution is YP. Okay. YR equal to y particular solution plus y homogeneous solution. This is all possible solution. Right, all possible solutions. And this one is all possible homogeneous solutions. Homogeneous solutions. All possible homogeneous solutions in this one. And this one is all possible solutions. They are plugging the initial condition. Determine R i's. Then you have the final answer. Final answer. Alright. Yeah, because in YH you have alpha 1 to alpha m, right? Alpha m, they could be any constant. It's free. They are free coefficients. But plug in the initial condition, finally you can determine those alpha. So YH will be just one result, not all possible result. Right? Here's all possible result. All possible result. Then plug in the initial condition, determine alpha s. Then just one solution. Just one solution. All right. Yeah. Okay. So this is for the system. You find the input. You find the output. Okay. That should be all. So we have studied. We have these four. So for signals, we have 4 topics, and for system, we also have 4 topics. Okay, that's all for this review. And if you have any more questions, I will be in the Zoom meeting this afternoon from 4 to 5. So see you afternoon. Bye bye.